Hello and thank you for joining us. This is part 1 of a tutorial created for students studying in the Ocean and Naval Architectural Engineering discipline at Memorial University of Newfoundland's Faculty of Engineering and Applied Science in St. John's, Newfoundland, Canada. The tutorial is primarily aimed at late intermediate and early advanced naval architecture students looking to develop their familiarity with GHSPort's popular and powerful General Hydrostatics software, colloquially known as GHS in industry. This tutorial is organized sequentially and aligns with but does not subscribe to the standard 3-day introductory GHS training course that is provided by GHSPort. The topics presented are arranged in a particular order that builds on prior material. Consequently, some explanations of program features are split to provide necessary prerequisite information. Then, at a later time, the full use of a command or intent is better articulated and we consolidate the knowledge. I recognize that this can sometimes feel incomplete or disjointed. Please be patient and trust that the tutorial will resolve this sense of unease. Sometimes, when learning a new skill, we simply have to accept that some aspects of the task develop as we become more familiar with the task. These tutorials assume no familiarity with GHS. However, a familiarity with personal computers using the Windows operating system is assumed. The tutorial begins with an overview of GHS's capabilities, limitations, and layout. The material then progressively builds to introduce GHS modeling skills, the GHS command structure, and an overview of GHS's modeling tools and the model organization. Following this, the tutorial delves into the basic hydrostatic report generation, formatting, and developing reports for differing stability conditions. We will then examine ancillary criteria such as longitudinal and transverse moments, as well as imposing wind and roll criteria. Finally, we will consider damage stability criteria and basic strength criteria. The series concludes with a brief overview of some desktop commands that facilitate more efficient ways to navigate through the command structure. The important concepts and principles of GHS will be presented, but it is important to recognize that these tutorials in and of themselves do not represent a complete user's guide to the program. The GHS User's Manual is the complete reference document. Links and information to access this document are provided on the last slide of the tutorial. We will be striving to present an introduction to 90% of the common naval architectural tasks that the software is typically employed to do. However, in the event you as a user are ever stuck for answers, the majority of the GHS User's Manual is accessible directly through the Help menu in the GHS software. By the time you finish going through this document, you will have the skills to produce a tremendous volume of useful work using GHS. You will also be oriented well enough with the software to employ the User's Manual to extend your knowledge. However, the objective of today's lecture is to increase your understanding of the uses and method of applying the GHS software to aid in the design and development of naval concept vessels or manuals of trim and stability. By the end of today's lecture, you should be able to describe the purpose and use of GHS, identify typical applications, explain the layout and main command window, and activate the help file to further your independent learning. GHS is a widely used software-based man-machine interface, and it's employed for hydrostatic analysis. In particular, the software is highly appropriate for static and quasi-static analyses of ship stability, including intact and damaged stability configurations and loading condition analysis. It can also be used to simulate behavior of both floating and supported structures, featuring ground reaction forces or other forces. This makes it very useful for the simulation of salvage, crane, and heavy lift operations. In my experience, I have primarily seen GHS used in naval architectural design offices for the assessment and creation of manuals of trim and stability or stability booklets. To accomplish these tasks, the GHS program uses a 3D geometry model of a ship hull and its arrangements. From this model, the program accurately and efficiently generates volume integrations to assess stability conditions from the first principles of naval architecture. Now, having said that, given the strengths of the software that I've already identified, you may have intuited what the software is inappropriate for: dynamic analysis. If you are concerned with the dynamic movements of your hull form, such as motion and waves, resistance and propulsion, or maneuvering, I would suggest you consider software packages that are well known for their ability to conduct such work. 3 applications that come immediately to mind are Shipmo 3D, MaxSurf, and Orca 3D, all of which are addressed in their own separate tutorial series. So if you're interested in those, check those tutorials out. Anyways, back to GHS. Fundamentally, GHS is not only a software program, it is a rudimentary programming language that has its roots in the DOS command structure. Subsequently, we need to have an appreciation for the fact that as a function interpreter, the machine simply takes the instructions we provide to it and programs them into a series of algorithms and equations so that humans don't have to laboriously crunch these iterations by hand. As a result, if we incorrectly enter information, we get spurious results. So, first and foremost, we need to know that GHS interprets model information and hydrostatic inputs through an American or US customary lens. In other words, the default coordinate system and units of weights and measures is the American coordinate system. Referencing the image in the slide, we can see that the coordinate system of the ship originates at the bow, usually at the keel or a common reference point if a sub-keel baseline is used in your drawings. It is customary to assign the primary longitudinal axis to the x-coordinate, the transverse axis is assigned to the y-axis, and the vertical axis is assigned to the z-axis. In this case, we can see that the positive longitudinal axis extends aft, the positive transverse axis extends to starboard, and the positive vertical axis extends upwards. Alternatively, many nations and their associated ship design offices produce drawings and designs that orient using the European coordinate system. Referencing the image in the slide, we can see that the coordinate system of the ship originates at the aft perpendicular, usually at the keel or a common reference point if a sub-keel baseline is used in your drawings. Like the US system, it is customary to assign the primary longitudinal axis to the x-coordinate. The transverse axis is assigned to the y-axis, and the vertical axis is assigned to the z-axis. However, in this case, we can see that the positive longitudinal axis extends forwards, the positive transverse axis extends to port, and the positive vertical axis extends upwards. Now that we've covered the housekeeping items underpinning our use of GHS, let's get into the details. GHS can most easily be started using the Windows shortcut located on your desktop, or by accessing the GHS executable contained in the Windows Start menu. When we first open GHS, a dialog box called the GHS Executive is normally active. Let's exit the Executive Wizard dialog. Now you will see a blinking cursor on the screen. This is the command prompt for typing commands directly into the program. For example, if we close the wizard, we can now see that any time the wizard can be reinitialized by typing the command run executive.wiz into the command prompt. In most cases, the command name can be abbreviated. The minimum abbreviation for commands is always indicated in the help menu through the use of capitalized letters. So, now that we've reinitialized the executive dialog box, let's discuss it very briefly. The executive dialog is a file management wizard, which has a built-in help system that can be used by anyone who is new to the program. Anytime the menus are active, the executive can be quickly brought up since it is the first item in the wizard menu. It can get a bit annoying to constantly have to exit the dialog if you're frequently closing and reopening GHS. So the automatic appearance of the executive at program startup can be toggled on and off by pressing the executive's help button, and at the top of the executive help screen selecting the appropriate button to toggle off the automatic startup appearance. Now that we've exited the executive wizard, we can see somewhere on your screen a blinking cursor. This is the command prompt for typing the command directly into the input window. For example, we've already tried running the executive.wiz command to restore the executive dialog. A quicker way to find out the minimum abbreviation is in the help menu, where it is always capitalized. In order to access the pull-down menus, you will have to close the executive wizard dialog. So let's go ahead and do that now by selecting exit if you haven't already done so. Now on the screen we have the main display open. You may notice that your display looks somewhat different than mine. There are slight discrepancies depending on the version of the software you are using and also the organization that owns the rights to your license. For the most part though, your display should resemble mine, or you can adjust it to resemble my display using the options in the View pull-down menu. Or not, I'm not the boss of you. Alright, so let's begin by looking at the main display. The GHS main screen depicts the various elements found in the GHS user interface. The window bar at the top displays the program name and project name if they're defined. Otherwise, the display just denotes the geometry file name. Examining the menu bar, we can see myriad pull-down menus, including File, Report, View, Project, Wizard, and Help. Note that the first letter of each menu may be underlined in your version of the software, indicating that these menus can be accessed via a hotkey. Just press the appropriate letter to bring up that menu. Next, let's look at the title bar. The title bar displays the title name, if defined. We can also see the header with data box showing on screen. If you do not want to see this data at all times, it can be turned off by using the View menu. The logo screen background may show the GHS logo in your software or your organization's logo. This can also be toggled on or off via the View menu. The display/command area comprises the majority of the main window. It is configurable via the View menu. Using the View menu, you can change the layout, display, or color scheme of the window. The status bar is located on the bottom of the main window. This bar displays the working folder, the report file, and the unit settings. Function keys, footer buttons, also known as hotkeys, are displayed in this bar and can be configured via the key command. Now let's take a closer look at the pull-down menus. Located at the top of the GHS screen are several pull-down menus. Almost all of the activities that you access through these menus are also available through commands as well. As you become more familiar with the command prompt in GHS, you will naturally gravitate away from the menus and towards the command prompt for speed and convenience. For demonstration, I'm simply going to select a command from the pull-down menu, and if you watch the screen, you'll see that the appropriate command is populated in the command output window. This is important to note for the future when we want to start writing our own run files. At any step along the way, if you get lost or are confused, the menu that you will find most useful is the Help menu, which provides quick access to nearly all of the GHS user's manual. It is organized by command name, making it a breeze to look up a command's description and parameters. Moreover, there's a global search feature allowing you to search the entire manual for any word. I'm going to open the Help menu here using the pull-down menu. Note that the menu opens in a separate window that stays open until you deliberately close it. By right-clicking anywhere in the Help window, we can bring up the Help index. I'm going to select the keyword draft, and we can see that the description of the draft command is activated. Now, closing out of this, I'll use the command prompt and type the keyword help, press enter, and we can see that this is now another convenient way to access the help index. By default, GHS will use the printer you have set up in Windows unless you specifically direct it to use another one. You will notice there is a separate report menu where all of the report functions, including printing, are grouped together. If you want to change the printer that GHS will be using, enter the report menu and select Setup Printer. I'm going to leave mine as is for now since we've previously set it up. Similar to the printer setup, by accessing the File menu and selecting the Setup Paths option, we can enter the submenu, and within it, we can use the editor program to specify any text editor for editing your run files. Personally, I find Notepad++ most convenient for editing GHS files directly. As you become more familiar with the power of the GHS command language, you will probably want to have some of your run files easily available to you regardless of which working folder you are using. Examples of these type of files include general purpose run files that might be referenced in other run files. In this case, they would be called library files, and they would use the file name extension .lf. In every other way, they behave like any other run file. To help you corral these files, a user library folder can be established in which GHS will automatically look for your library files when needed. Enter the File menu pull-down, select Setup Paths, and you will find the User Library function, which allows you to establish the location of your user library folder. So let's summarize what we've discussed here today. In this video, we discuss the uses and methods of applying the GHS software to aid in the design and development of naval concept vessels or manuals of trim and stability. To aid with this discussion, we identified the purpose and use of GHS, looked at its typical applications, and explained the layout, program coordinate system, and main command window orientation. We also discussed how to activate a help file to help further your independent learning. So, now that we've completed the dime tour of GHS, I'd like you to run your own version of the software and see if you can complete the following tasks before moving on to the next video in the series. First, explore the pull-down menus and see if you can change the display format from the white and black display to a black and white display. While you are at it, try to change the command window to show all of the outputs in a single pane versus a split pane configuration. Once you've made it that far, use the pull-down menu to access the help files for 3 commands: change directory, draft, and status. Then have a read through the help files on these subjects. When you've finished that, close the help files and use the command prompt method to access the same 3 help files. This will help you familiarize yourself with the various ways to effectively access GHS's capabilities. Thank you for watching, and if you have any questions or feedback, please leave them in the comments below, and one of our admins will get back to you with an answer.